Okay, the last thing I want to talk about on this section, hope it's the last thing, is the chain rule, and that's point 7 in the box. And it says that d of u f t over dt is equal to f prime t, gosh darn it, u prime of f of t. You know, we normally don't write it this way for the chain rule. We would write it kind of like this. They didn't in your book. So what's going on here? What's happening? Well, we've got here a vector function. But inside of it, instead of having u of t, which we've been used to, right? We now have u of some function of t. So imagine that this is u a squared. Okay? So that means instead of plugging in t, we plug in a squared. And when we take the derivative, we've got to allow for the fact that this is a function that's more complex than this. In other words, the derivative of t is 1. However, the derivative of a squared is 2a, and we've got to take that into consideration. So when we look at this, this is just the application of the chain rule. So we take the derivative of the x, the y, and the z components, plugging in f of t, okay, and then we multiply that by the derivative of f of t. Okay, just classic chain rule. You apply it independently for the x, the y, and the z, and that gives you your answer. The thing to remember here is this is a vector. That's a vector. This and this are just scalar functions. Okay, in this case, x squared. So what we'd have is whatever, in this case, whatever u prime is of a squared times 2a. So each, the x, the y, and the z components in this vector, the derivative of this vector, get multiplied by 2a. I hope that's clear.